We begin this lesson with an example that consists of two static methods in a class called maximum finder. So let me go ahead and open up our IDE and we'll pull up the source code. Now basically what we have in this example is a main method that's going to input three double values from the user and then pass them to a method named maximum, which you can see declared down here towards the bottom of the class. And as part of this example, what we want to do is talk a little bit more about why main is static and the fact that main, being a static method, can call other static methods within the class. So let's first take a look at the main method, and you can see lines 8 through 22 define that method, and we prompt the user initially to enter three floating point values and press enter after each one. And then at lines 13, 14, and 15, you can see we're using convert.toDouble to take the line of text that was read in from the user and convert it to a double value. And once again, we are assuming the user is properly typing those double values. So let me just go ahead and run the program for a moment so we can see it in action here. So we'll initially type a couple of double values, 3 of them to be exact. And as I press enter on the third one, we can see that the maximum was the second value that I entered, 3.33. And it doesn't matter what order these three values are in, the maximum function will always, or method rather, will always return the largest of those three values. So after we read in those three values, we then pass them to our method named maximum, number 1, number 2, and number 3 being the three variables that we just initialized in lines 13 through 15 with the user input. And by the way, notice I am declaring the variables as I need them in this example. And then finally at line 21, we display the result, maximum is, plus the value of the variable result. Now this is interesting because any value can be added to a string in C#, and that value will automatically be converted to a string. If it's a simple type, such as a double or an int, then the value is simply converted to a string and its text representation is added to the string. In the case of an object being added to a string, every object has a special method named toString with a capital T and a capital S that will implicitly be called if you add an object to a string. Now, you'll notice back here at line 18, when I called maximum, I simply listed its name followed by its arguments. If I'm inside of a static method, such as main, within a class, I can see all of the other static methods of that class. So because main is static, and because I declared maximum as static, main can directly invoke maximum. And so the maximum method is defined here at lines 25 through 38. You can see that it's a public method, which means we can actually call it from another class if we wanted to. It's static, which means I don't need to create an object of my class maximum finder just to be able to call this method. And it returns a double and receives three double parameters that we're calling x, y, and z. As far as the logic of the method is concerned, I initially assume that the first parameter x is the maximum value and I assign it to the local variable maximum value. Then I check to see if y is greater than that maximum value, and if so, I assign y to the variable. And I check once again to see if z is greater than the maximum value, and if it is, I assign it to maximum value. And then by the time I get to the return statement, maximum value will have the largest of those three values that were passed to the method. We'll then return that back to line 18, store the value in result, and then display the result in line 21. Now you'll notice we used several different local variables inside of this example. We've got 4 of them here in the main method, and we also have a local variable in the maximum method. And of course, the scope of a local variable is the block in which it's defined. So for example, at line 13, the variable number 1 is known only from the point at which it's declared here and up until the end of the main method. Similarly, the double variable maximum value is known only from line 27 to the end of the maximum method. you should only be declaring a variable as a non-local variable, or what we call a field of a class. A field is either an instance variable of the class or a static variable of the class. You should only use fields of the class if you need to maintain information between method calls or as part of an object of a class. So you saw with the gradebook that we could have instance variables to maintain state information for a given gradebook object. You can also have static class variables, as they're called, which we'll discuss more in a later lesson, and those variables also exist beyond the scope of any one method and can be used to store information for use in other static methods of a class. Now, the reason that the main method is declared static has to do with the initial startup of an application. When you first start an app running, the class that contains main, the so-called startup class, is going to be loaded into memory. Now, when it's first loaded into memory, no objects of that class exist yet. So in order to get the program up and running, we need kind of a bootstrapping mechanism, if you will, to start the app running. And what the runtime is going to do is, for the class that contains main, it's going to invoke that class name .main to start the program running, which is a call to the static method main, at which point main decides what to do to get the program up and running. And in our case, in this example, it reads in the input, passes the values to maximum, and then displays the results, and then the program terminates. It is also possible in .NET app development to have multi-threaded applications where main is simply the starting point of the app, but not necessarily the ending point of the app. And a good example of that is any graphical user interface application. Main will get the program up and running, but from that point on, there's additional threads of execution, such as what's known as the event processing thread, and that is there to continually receive user interactions through the graphical user interface. And we'll talk about those issues in later lessons as well.